So welcome, everybody, to Unstructured Data Meetup. I'm going to be your host tonight. I'm Christy Bergman. I'm a developer advocate at Zilliz, and we're the organizers of this event tonight. We are the maintainers of open source vector database Milvus. This is me. Feel free to follow, connect with me on LinkedIn. And a good way, just a few little words about introduction. A good way to think about vector databases is they're open source or closed source. And Zilliz and Milvus has a foot on both sides. So Milvus is open source. It was donated to the Linux Foundation. It has a very generous Apache 2 license. Because it's part of the Linux Foundation, we cannot change that license. So it's going to remain open source. It has more than 28,000 GitHub stars, more than 50 million Docker pulls. We're 113 million Series B. And one nice thing about when you're using Milvus, like if you're using Python, for example, and you leave off the definition of which index, it'll default to the system index or auto index, which on the open source side will be HNSW. But then if you're using that same code on the managed Milvus, Zilliz Cloud side, it will default to a proprietary faster index. And the Zilliz Cloud runs on public clouds, AWS, GCP, Azure. So you probably have heard about the 3 pillars of generative AI, the compute, or the silicon, the LPUs. Why did I start with LPU grok? The least known, the CPUs, the GPUs, the TPUs, models such as OpenAI or Meta's Llama or Gemini, for example. But we think the most important part is the data. So the unstructured data is anything that besides spreadsheets. So most of the world's data is unstructured. So text, images, videos, sound bites, and there's just a lot of opportunity in the unstructured data space around this. And we're going to hear a couple really great talks. Actually, all 3 talks tonight are going to be really great, addressing issues or challenges with unstructured data tonight. Keep your eyes open for Q4 this year. We're going to have our very first Unstructured Data Summit. And also, you might want to take a picture of this. We're going to do a raffle at the end of the night for 3 Zilliz hoodies. So with that, I'm going to hand it off to our first speaker. Oops. Oh, shoot. Oh, it's not coming through for some reason. Oh, there it is. Sorry. Hold that up there. And a little hack is, in case you've already starred our GitHub Milvus, do it again. Because I'm gonna start from tonight counting people and entering people in raffle. Okay, so with that, I'm gonna hand it off to our first speaker, Alex Bonnet, who is lead ML solutions engineer at Encord. Encord is an AI company that specializes in computer vision. Alex previously built 2 companies in the insurtech and fintech sectors. He's got a master's in theoretical physics from Imperial College, and he's going to speak to us tonight, garbage in, garbage out, why your data curation is killing your AI models and how to fix it. So welcome, Alex. Thank you.
Fantastic, thank you. So yeah, I'm Alex. I'm here to talk to you about garbage in and garbage out, why poorly curated data is killing your AI models, and we'll also talk about how to fix it. So it's not all doom and gloom. So by means of structure, start off with a short introduction, get us all excited about AI. We already, of course, are, but sort of setting the scene there. We'll then talk about why data quality is so important and often overlooked. And then we'll give you some of the trends that we see in the market, as well as outlining some of the steps that we see in the quality data production pipeline. So I'm Alex, lead the solutions engineering team at Encord, and I'm extremely privileged to be able to work with our customers on all sorts of cutting edge and weird and wonderful use cases. So we get to see our customers using our platform to build some of the most advanced applications across a wide range of AI spaces. Now, as Christy mentioned, we're a data development platform. So we essentially take everything from the raw unstructured data piece, so data just sitting in S3 buckets in various storage locations, help our customers index it, curate it, understand what's in the data, and then feed that data into the correct enrichment processes. So either kind of machine-driven or human-assisted, especially relevant in expert use cases, and then all the way through to the deployment of these models, where we help our customers monitor these models in production and understand across which sort of parts of the data they're performing well or poorly. So to drive that iterative cycle of virtuous model creation. Now, of course, everyone here is very much plugged into the space, but I just wanted to show this graph to get us excited about the both academic and application parts of AI. So the research that's coming out on all fronts of AI, so on the compute, on the models, has really been exploding in the last 5-10 years. And we see this every year at CVPR. We see higher quality, models, we see higher quality research, tackling more and more complex and niche use cases. But the thing that I think is the most exciting is the fact that this is now reaching the hands of everyday consumers. It's out in the wild. It's also not just being used by run-of-the-mill consumers who have no idea about AI necessarily, but also by people within enterprises who may not be technical, but are starting to see huge increases in productivity in their AI workflows. Now, one thing I like to do, especially when you're at the coalface in any industry, is to kind of zoom out and see, like, how do other players see our industry? And this is the most recent Gartner hype cycle graph, and it positions our niche, computer vision, at the plateau of productivity. Now, we don't need to talk about how computer vision is mixed with other pieces like foundation models, synthetic data, generative AI, all very relevant to computer vision. So there's a bit of a disparity there. But I would very much disagree with the position of computer vision on this graph. This, to me, says that expectations are set, productivity is constant, and we're not going to see any kind of new game-changing applications in the vision space, which is fundamentally related to quite unstructured, difficult to understand data. So we'd either pessimistically position computer vision back in the trough of disillusionment, or zoom out and expect an enormous kind of latent tail of productivity, right? And the reason for that is that fundamentally the data landscape has changed. So models, of course, still ever increasing in their power, but the data that we have available to us to configure these applications has really changed in scale and nature. So the shift we've seen from kind of traditional AI applications to what I would call modern AI, so traditional AI kind of 5-10 years ago, reserved to tinkerers, really having to be built from scratch on small data sets in very ad hoc kind of workflows. This has completely changed, right? We're lucky enough to build on the latest and greatest foundation models that exist. We're tackling extremely complex use cases, especially in the multimodal area of things, so video, audio, and also sensor data, which is still an incredibly early kind of area of the unstructured data landscape. And most excitingly, again, as I said, this is starting to land in the hands of general users. So we have more and more of a responsibility as AI builders to create models that are of high quality and can be relied on by users out in the wild. Now, as Christy mentioned, the pillars of AI here, compute, models, and data. At a raw level, compute has become somewhat of a commodity. Of course, getting your hands on large clusters of the most recent GPUs can still be a challenge, but that's more of a kind of production issue rather than a fundamental technical limitation. The models piece, models have become increasingly powerful and difficult to build from scratch and to architect and pre-train from scratch. So we need to use these as foundational pieces to configure them using our application-specific data in order to produce very, very powerful and domain-specific models. Now, as I mentioned, it's become easier than ever to pull these resources out and start to use data as a configuration layer over these fantastic foundations that we now have. And we see the biggest challenge that AI teams are looking at being that data exploration and data curation and cleaning piece. So as I mentioned, we're very lucky, do not have to start from scratch. Sometimes we have customers or prospects come to us and say, my application is so specific, I have to come up with a whole new type of model. And if that really is the case, then I would say that's not a great position to be in, because you're going to have to go up against some of the largest players that have spent millions of dollars and have the largest and most sophisticated research teams to even get something workable in today's AI era. So enough with the sort of hype and positioning. Why is data quality so important? Now, this may seem incredibly obvious, but bad data definitely equals bad models. So this is the cleaning part of the coin. And we've seen sort of text-based models trained on a very large corpus of noisy data, right, available on the internet. But the techniques used to filter that down are relatively well understood and also quite cheap to run at scale. So even then, we still don't have a completely solved problem. I think we've all seen the sort of memes of, early Gemini usage giving completely, wild and incorrect responses. And that clearly aligns to the text part of the curation still not being completely valid. But when we start to move into more complex modalities, so imagery and video, for example, we'll remember the sort of Getty images and Stability AI debacle of producing generative images with watermarks in them. And that is clearly not a model problem, that's a data curation problem. So the models were not shown the right kind of data, they were shown essentially, polluted data. And whilst this, sort of led to a legal ramification and maybe a usage ramification, it's still a relatively innocuous problem compared to, for example, if you wanted to train a generative AI model on all the data, let's say, present on YouTube, right? This data is extremely high scale and also contains a lot of bad stuff. And it becomes very, very hard to analyze this data at scale. So for example, let's say an innocuous video with a potentially harmful audio track. We want to really make sure that these do not come into our model training pipeline. Flipping the coin on the curation piece, and this is a bit more positive, right? Great data equals great models. If we're taking a state-of-the-art model that has a general understanding of the world, we want to make sure that it can solve our specific use case. So let's say we're building a model to detect bad welds in an industrial application, or a model that is going to be an assistant to surgical robotics processes. We need to make sure that it's being trained on data that is going to be extremely relevant to our use case and is not going to fail when those edge cases come up because it hasn't seen them. And the great data kind of curation process becomes even more relevant when we have expert use cases. So a lot of enriched kind of metadata that's present in the training pipeline can be auto-generated, but for the hardest cases, it involves leveraging expert users that are going to be very expensive, right? If we take a doctor and we're going to be showing them easy fracture cases, that's not a good spend of our time or resources to build the latest fracture detection model. So I quite like this example. This is from a paper called Eyes Wide Shut, and it outlines some typical VLM failure cases that we would determine to be trivial. So if we zoom in on one of them, you can see this school bus example. And VLM, so this is GPT-4 with vision, was asked, is the school bus parked facing the camera or away from the camera? And it gave what to us is a sort of comically wrong answer, but in the real world would have extremely devastating applications. And the only way that the researchers were able to find this data was by exploring the embedding spaces of the images and looking for divergent embeddings between different models. Now, this, again, as I mentioned, is something that's going to have extremely real and measurable real-world impact when deployed into the wild. And we need to make sure that that entire data curation and cleaning pipeline is well set up to function at scale so that we can have something usable. Now, how many of you would deem this to be high quality data? This is a panoptically sort of segmented scene. You say this is high quality data? Yeah, seeing a few nods. So this, I would say 5-10 years ago, was high quality data. We didn't have enrichment models like SAM, for example, to help us auto segment these scenes. We're not even talking about the video aspect of this, right? So we need temporal stability, etc. But this is quite high quality data, and it was a few years ago. But this kind of high quality data would not allow us to do this. So this was a presentation by Wave this year at CVPR, where they are at the cutting edge of VLAMs. So starting to look at cross-modal applications where we have both video streams and also explainable text model that allows us to query what the model is doing and what it's thinking. And if you think about the data generation pipeline in this particular application, if we had hundreds of millions of recorded video assets and we wanted to enrich them with additional text data to give our model context, we need to make sure that we find the most relevant scenes. We don't want to do this at large scale, incur extremely high cost, and send the wrong data to our models. We want to make sure that we pick out the most relevant scenes. And you can see a cyclist here. If we only had highway data, we didn't have a well-balanced data set, we wouldn't be able, the model would not be able to explain what it's doing in this particular situation. And so with much richer data compared to, let's say, just text, when we're starting to look at video and audio, that curation piece becomes ever more important. Now, one example that really brings this together is Lava Med. So Lava, open source model by Meta, trained on thousands of GPUs over the course of several weeks, very, very expensive to set up, and has a generally good understanding of the world. But it is not a medical specific model. We'll see later, it doesn't have a good understanding of this field. Now, these researchers wanted to fine tune it, which is what we're seeing more and more as we're now lucky to build on foundations. They wanted to fine tune it for a medical use case. Now you can see here there are kind of two main stages to their training process, but in the first one, they used 600,000 samples. So these were 600,000 image text pairs taken from papers and textbooks. Now, who thinks that the 600,000 sample data set was 100% of the data set that was available to them? 50%? 10%? Any hands? No? Maybe 10%? Yeah. So this was actually 4% of the available data. The data set was PMC 15M, so 15 million of these data assets. And if we think to 5-10 years ago when data availability was lower, we potentially would have just shown our model all of these examples. But in this case, they wanted to make sure that the concepts in the data set were well balanced and that they could show their model the most relevant data. So they spend a lot of time doing kind of semi-automated, but also manual curation of the data, so manual configuration of the curation process to make sure that they had a really, really well-balanced data set for that concept alignment phase. And this is not just in terms of making sure that our models have a well-balanced understanding of the data set, but also on a cost basis, right? So they were able to do this first stage of the fine-tuning in 7 hours on 4% of the data set. And if you scale that up to if they'd used the whole data set, this would have been a far longer time to value. Now, the second stage is even more interesting, where they used an order of magnitude less data, so 60,000 samples. And this was the kind of instruction tuning piece, where they generated kind of question-answer pairs for these particular images that were being shown to the model. And this is quite expensive to run. So they used GPT-4 along with doctors to generate the fine-tuned data that was going to be fed into the, to generate the data that was going to be showed to the fine-tuning process. And the result of all this, so training on 4% of the data set in the first stage, then 0.4% in the second stage, was this. So at the top, you can see an X-ray image, and you can see Lava's answer at the bottom. So it's telling us that this was likely a medical illustration. Now, I'm not a doctor, but I'm pretty sure I could have told you that, and I wouldn't have needed to train on thousands of GPUs. Whereas Lava Med, which is is trained on a much smaller data set, so a highly curated, very clean data set, was able to give us this very, very rich context. So the take home here is that we can spend less money, we can wait for less time, and we can build on these foundations to generate very, very high quality models. So to recap, the two kind of main pieces here of the data processing sort of pipeline are the cleaning and the curation, right? So removing bad, corrupt data or redundant data, as they did, for example, Lava Med, and also curating the data so that we can find the most relevant assets to spend our time and money on enriching them so that we can then show them to our model in an efficient way. So what trends do we as a data platform see in the market? So what we used to see at the low end of the scale was this quite linear pipeline with few steps where we just collect all the data we have, we send everything either to manual annotation or run some pre-annotation models with humans in the loop, and then we train our model, we deploy it, and then we forget about it. But this doesn't work on highly specialized use cases at the 100 million, the billion scale with highly unstructured data. So with, for example, multiple modalities with very rich, very long videos. And you can see this middle section, which is where we focus on today, which is the cleaning and the curation piece. But we as a platform touch all of the pieces in yellow here. So closing that loop as well once the models are out in the wild. So we can go for another little show of hands here. How many of you are essentially looking at your large corpuses of unstructured data and using, let's say, some sort of embeddings model to understand and organize your data? Yeah, a couple people using that. How many of you are spinning this up kind of ad hoc, or do you have like a proper persistence layer to manage that entire life cycle? Okay, a few ad hoc users. So we see a variety of kind of levels of sophistication, going all the way from just manually looking at the data, the worst probably being just scrolling through 8-hour-long surgeries to see where the relevant points are, but all the way to spinning up, clusters to calculate embeddings, but not necessarily with proper kind of persistence layers in order to capture the results of that data curation process and then close that entire loop. So, the downsides of not cleaning and curating, clearly spending a lot more time to bring these models to market, spending a lot more money in the annotation, enrichment, and training piece, and then ending up with really low quality models. So there's a case study that I won't go into, but I would urge you to look at it on our website. One of our customers used our curation and cleaning process, and they basically were able to increase the quality of their production models with far, far less data. So what are some of the techniques that we see our customers use in order to change this kind of broken curation and cleaning process? So more often than not, we actually see people, even at the kind of basic level, having huge amounts of duplicate data in their storage buckets. They also will have corrupt samples, they'll have noisy samples where the data was poorly encoded, has completely irrelevant information across large swathes of it, and finding outliers that are not going to be related to their models. So they've maybe just brought in a poorly curated bucket where lots of different users have uploaded data within the organization and they have no idea what's in it. On the curation piece, there's no essentially high quality prioritization of the data to be sent for potentially expensive enrichment. Now, we're for a few kind of pieces here. One that we see, especially across more kind of frontier modalities, is computing quality metrics over the data. Right? So these could be heuristic based, see people looking at blurriness, brightness, etc., but also embeddings based, which I think we have a great talk on a bit later. So embeddings as well are an approach for highly unstructured data that we're lucky to be able to leverage, given that we have such great open source embeddings models to allow us to start to curate very, very highly unstructured complex data. Now, on the cleaning piece, we see embeddings-based approaches where we can find potential outliers in our data, but also apply auto-cleaning techniques. So you can see here, we've got automated section processes for data that is not going to be relevant to our model and that it's not going to be able to properly understand once out in the wild. So the curation piece that I want to first talk about is around unstructured search. So searching over embedded videos, let's say we have a large corpus of videos of our vehicular assets driving around. We can do a natural language search to find relevant pieces. So here's school. So let's say, going back to that example of the school bus that was clearly being failed during our model deployment. We find all of the schools here through natural language. And then we're able to go one step deeper and drill down into the assets to look for interesting moments, right? That are going to be the ones that we need to highly curate and show our model so that it can be trained on and have a proper understanding of these situations. So in this case, within a video where we were near a school, we can go ahead and look at something like, for example, a metric that's been computed, like diversity in this case, and find rare moments. So you can see here a pedestrian crossing in front of a school. And that's something we really want to be able to understand properly in a deployed self-driving model. Now, the second kind of piece as well is around metadata validation. So in what we're seeing here is essentially an embedding of classes that have been pre-labeled on some data assets, and these are colored by class. And you can see that most of these clusters are, well separated, but we have this mixed cluster kind of in the top left-hand corner. So you can see here a mix of classes, which is suggesting to us that these are potentially mislabeled, right, or pre-labeled. And so drilling down into these, we can see in this particular example for, let's say, a shopping use case, where we have our clear flour examples that have been detected as almond milk examples. And we can zoom out and take these in two pieces, one for more complex data, so imagery in this particular example, but potentially video and audio, where we need to find these outliers where we've mislabeled data, where we don't have enough data to tackle specific use cases. And so this piece is going to be talked about, I think, later around the embedding of our unstructured data assets, where you can see that using off-the-shelf models that we might already be lucky enough to access, like CLIP, on a class-based embedding on this projection, we don't get fantastic separation, right? So we're not able to use this as a component of our curation and cleaning process. By doing fine tuning as well on the data filtering part of things, we're able to get a much higher quality embedding of our data that we can then explore using structured pipelines and automated techniques. So, I asked you, would you rather your embedding space look something like this or like this, right? Where we can properly explore and curate the data.
5 minutes.
So to summarize, what we have seen, especially at this much higher scale, where we have multiple modalities, is that it becomes much, much harder to actually find the right data, because it is so complex and it has so many different characteristics, especially when we're considering cross-modal interactions. And so we need to have a really, really solid pipeline in place so we can automate the data cleaning, so that we can remove all these bad samples that might be nefarious and affect our models in a negative way, but also can be highly curated, so we can spend our time and our money on the right enrichment and training parts of the pipeline. What this allows us to do, especially at this much, much higher scale in this era of modern AI, is to speed up the process, move more efficiently, and make sure that we can have much, much more reliable models in production. Thank you. We have a QR code if you want to scan it to go on our website, and we're happy to talk more about unstructured data. I'm happy to open up for any questions as well.
All right, let's thank our speaker. Thanks, Alex. I think we have time for 1 or 2 questions from the audience. Okay, I see one over here.
Hello. Thank you so much. Wonderful talk. I wanted to ask, does your platform support any video processing in terms of handling data drifts and identifying whether there's a change in distribution of the images? Yes.
Yeah, that's a good question. So we are actually a video-first platform. So we support all kinds of modalities, so audio, text, but primarily kind of started in video. And across videos, we see essentially different levels of granularity in the curation process. So they could be frame-based. So for example, that natural language search that operates just on a frame basis, but also whole video based. So in a video, how are distributions of various characteristics changing? And then also at the kind of whole video embedding. So if we embedded clips of that entire video, how are those distributed across our data set? So we very much support video. That's our sort of focus. Yep.
When you showed the clusters that you got out of CLIP that were not ideal, how do you know if it's CLIP that's the problem or if it's the hyperparameters that I'm putting into UMAP or k-means or something?
Yeah, that's a good question. So, of course, with the projection, it's much harder to tell us for illustrative purposes. But in terms of knowing whether it's the model, I think there is, we focus on the data, right, as this configuration piece. But using the data can actually tell us a lot about what we need to do, even in the model parameterization piece. So I think my point there is that we don't need to rebuild a model from scratch, but we can use the data analysis to understand, okay, maybe we need to tune our loss function, right? Because we've seen issues in the way that the data is being handled and processed. So yeah, it can definitely be a model issue, but fixing that is coming from the data, right? We're not just looking at the re-architecting a full model. We're saying, okay, given the data, what pieces can we tune a little bit to get a better outcome? So that was a model fine-tuning piece, but very much driven by a failure of the model on the data, and that being shown by looking at whole data analytics and like quality metrics and distributions.
Okay, and if you didn't get a chance to ask your questions, you'll be sticking around afterwards. So yeah, you can look for Alex afterwards. Thanks. Let's thank our speaker again. So I missed the chance. I usually ask at the beginning how many people here are using Milvus or Zilliz. If you are, please come up to me and let me know, because we'd love to get you up on the stage. Okay, and the other thing is kind of a ritual here is we ask if there's any job openings that anybody has. At the end, we're going to let you make the stand up and yeah, make your pitch for your job opening. So next up. So our next speakers are Joe Maionchi, and who's the VP of R&D, and Hendrik Krack, who's the developer advocate at Apparavi. Joe spent his career in unstructured data. Previously, he was director of engineering at Simplicity, EMC, and Veritas. He is passionate about getting stuff done, fixing broken things, and forging collaborations. And Hendrik is co-founder of the Halt AI Society in San Francisco. His work spans from developing AI to renewable hardware and fostering community around technology and climate. And I just want to give a plug here because Joe stood up at the end of one of these unstructured data events and announced a job opening, and Hendrik went and they met here, right here, and now they're working together, and now they're speaking.
Right, thanks for that introduction. All right, let's see. There we go, perfect. Great, all right. Yeah, thanks everyone for being here. This is amazing. I also just recently moved to SF, and I think being here right now at the epicenter of unstructured data is yeah, insane to me. So thanks for listening in. Let's talk a little bit about unstructured data. We really could have not asked for a better introduction than from Encord, because similar to Encord, we also think about garbage in, garbage out, or as we like to put it in Munich in our office, similar. We really think that accuracy is really important, and accuracy comes from quality input data. But maybe you're not training your own large language model. Maybe you're just using something like a RAG-enabled chatbot or something in that way. And even then, it's important for you to have the right information and the right data delivered to your chatbot, right? Another really important thing that I want to highlight is privacy. We've been seeing that a lot. I don't know if some of you might listen to the All-in-One podcast. There was an episode a year ago in August 2023 where they were talking about how every enterprise now wants their own intranet ChatGPT that has access to all their personal information, knows something about permissions and privacy. 1 year later, that problem is actually not solved yet. But if you bear with us for this talk, maybe we're going to show you our take on it. Let's quickly talk about the problem space again. I know many of us are working in that space, so you kind of heard this before, but 75 to 80% of enterprise data is unstructured, and the amount is growing at an incredible rate every single year. And we kind of went on that tangent, and we asked companies, why are you not using this? What is the problem? And they came back to us and said, well, we don't really know what we have, and we don't really have the capabilities to manage it all anyways. And then this was first ChatGPT, and now there comes another problem. They want to use AI, but they don't really trust the big open AIs of the world to handle their data securely through API calls. So there's these two big issues, and we at Apparavi, we're trying to help you solve those. So we are trying to create value for you from your unstructured data by never really touching your data. You can basically use anything from your object storage to conventional databases, file systems, whether that's in cloud or on-prem. And we will help you to do these, to discover your data, organize it, and act upon it. For now, we have 4 different solutions that we offer right now, which is Enterprise Rack and Data Prep for AI, which I'm going to talk about a little bit more later on. And then a legal part that helps you in case of a data breach, for example, and data intelligence and an automation IT piece. But before I dive into that, I want to give my colleague Joe here a chance to talk a little bit more about the core technology itself.
Thanks, Hendrik, and it's really great to be here. I want to first mention Operavi's been focused on the unstructured data problem kind of in general for the last several years. And only recently we've decided, hey, let's see if we can apply these solutions that we have to understand your data, understand where your risks are, your opportunities, and your waste, and basically funnel that towards your AI project. So we're really speaking to the AI developers out there who are spending some amount of their time trying to find the right data to feed to their AI project. So let me spend a few minutes talking about what the Operavi platform is. So we start with your data, right? That's the most important thing. We start there. And the key thing about Operavi is your data never has to move. So you saw earlier, someone was talking about data lakes, data warehouses. You don't have to move your data to get all these benefits. It stays exactly where it is. So the other key aspect of Operavi is you deploy it within your own environment. So this paradox of having to send your unknown unstructured data to some cloud provider to then learn about whether it was too sensitive to send to that cloud provider is kind of ironic. And we want to help you avoid that by just getting all that intelligence yourself. You don't have to send it anywhere, not even to Operavi. It stays in your environment. We have a very distributed architecture, so you don't have to manage a server farm. You deploy our application everywhere where you have this unstructured data. You segment out that data space, and you deploy our application. And this also means distributed metadata, distributed index, distributed vector store. It's all manageable because it's not huge. Of course, then you have to ingest that information into these nodes. And I just want to point out, we support over 1,000 different file types. We have fast and accurate OCR to do image, text out of images. We're always talking about text here. So anyway, you're able to actually view this insight and do all of the features of Operavi at the highest level in your organization, so you can actually see trends. You can make big decisions on what you have, where your risks are, where you can drill all the way down to the individual node, individual file, individual embedding even. So this aggregation is really powerful. And then we have some other capabilities I'm not going to spend a lot of time on, but the key here is Operavi is actually a very robust platform that does a lot of things. What we're going to be talking about here today is where we can help you with your AI project. So some of the things we do, which will probably be of interest to you as you start to explore further, the ability to understand the ownership of data and who has access to what, that's going to play into, in the future, multiple users using the same chatbot, asking the same prompt and getting different answers based on their access rights to the source data that fed those embeddings. That's going to be super key for you in the future. We have built-in actions within our platform that allow you to actually act, as Hendrik was saying, on those insights, on those problems that you've identified, right from our platform. So you don't have to go to each of these sources and manually take these actions. You can actually do that right from our platform. And then we have policies that allow you to schedule this and have it running continuously or on a periodic basis so that you stay compliant, that you stay avoiding all that redundant data, that obsolete data. You can basically keep it clean. We talk about clean data. You can actually use this to manage your data so it stays clean all the time. So in summary, your unstructured data stays where it is, and it stays private to you and you alone, or your company and your company alone. And you get the benefits of a lot of the benefits of structured data on your unstructured data, again, without having to move it or change it. So things like being able to query it, search it, do reports on it. You'll obviously learn a lot about your unstructured data, so you'll solve that problem of not knowing what you have. and you can scale for your entire enterprise. And that's key because a lot of times we're seeing that people are still in the POC stage and they're working on small data sets. How do you scale that out to your entire company? So we can help you with that as well on the data side. We're not going to help you necessarily build the app itself, but you can certainly spend a lot less time curating and finding the right data for each of those apps. And we're certainly thinking you're going to build more than one app. So if you can simply write a query to say, I just need this kind of data across my unstructured data for the company, for this app, you could just write a query and you can do this over and over again. It takes all that data prep time down to very, very small. So that's the quick intro to the Operavi platform. I want to hand it back to Hendrik to get into the details on our AI solution.
Right on. Thanks, Joe. Great. He went a little bit off script because he gets very passionate about this stuff. All right. Our enterprise rec solution, I think this is the most exciting part to show here for this community. So we built two first applications to feed into your AI projects. One of them is the semantic search retriever, which is providing you with a semantic search API endpoint that you can query against. So basically you walk through the entire data process, data pipeline that we have. It stores the data in our local in-house VectorDB, and then you can query against it and feed just the relevant chunks for your query into your project. The other part, if you're already a little bit further along on the journey, you already chose a VectorDB, you can choose one of our supported VectorDBs, like Milvus, for example, and you can feed that data right through the Operavi data pipeline and then right through into your chosen VectorDB. Why did we do this? Well, maybe a quick show of hands. Who of you has built a POC like this before with some of their unstructured data from a file system, cloud system, or anything? Good, I see a couple hands. Yeah, great. All right, amazing. So maybe you can relate to this. What we've seen a lot when we went to conferences like Databricks or different kind of meetups similar to this all around the US, we've seen that people have done this and they've got very excited about it. Most of the time they build really cool POCs and then they show it to their peers, and many of their peers, they like it. And then the peers shows to the boss, and then the boss gets excited about it, and jackpot, they get to build it for the entire enterprise. What then happens is you go on a search. Maybe you want to think about, okay, how I'm going to scale this up, how I'm going to build this to be, helping everyone in the organization. I want to include all the cloud service that we have, the communication, Outlook, Slack, Teams. I want to, of course, tap into the on-prem service. And then as you go along that journey further, you bump into some roadblocks. So you actually got to have to think about, okay, permissions, who gets access to which data? Is everybody be able to kind of query against all the data? What about HR and whatnot? File types, bunch of file types out there that, you got to figure out how to support that. Multiple cloud providers, fast retrieval, I could go on for some time. And then many people kind of get stuck on that phase. And that's why we started building that first endpoint, because we want to help you on that journey by doing all of that for you so that you can focus on what you really want to do, which is just building a great AI application, right? So the first thing you can do this is through the RAG as a service. That's how we call it. That's the semantic search endpoint that I just talked about. Or the other part is the AI data loader. And yeah, let's just give you a quick demo. I think we still have time. So let's tap into that. I'd love to show you how I built this personal assistant bot. Before I start getting into, writing some fancy queries and stuff, I want to show you how I got the right data into that, because that's really the most interesting part, because I think everybody here can spin up a Streamlit bot. So what you see over here is the platform that we have. On the left side, you see what we call like a mimicking enterprise system. So you can kind of see, okay, it's got a OneDrive connected here with some users. We have an Outlook, a bunch of users in there. SharePoint, Azure, heaps of drives on there. You get some information about how much data you put in. You get a PII count, personal identifiable information, for those who didn't know that term before. You get a projection on how much your unstructured data is projected to grow based on that. You got that IT piece that I was talking about a little bit earlier here, some stats on that, when people accessed what, who's got permissions to see what kind of data, and who created that as well from the data owner side. I'm not going to dive too deep into that right now. What I want to do is, since we're here at Milvis, I'm gonna show you how you can set up an integration. So these integrations are really key to what we do. We do two things with those. One thing is you can, for example, add an integration to put that into your a vector database, so like the Milvis part here, or you can also, we have other integrations too, relativity server, text output. You can also transfer some of your data, a certain subset. Let's say you have something on a file system and then you want to put it into some OneDrive. That would also be possible with a couple clicks from that platform. So let's go back though. What I want to do is I want to set up the Milvis DB. It's going to call that test for easy use. I'm going to spin that on my local host. Put that on that port. I'm just going to call that test again. I'm going to click validate. And now we're praying to the demo gods. All right. It should show up here very quickly. I'll give that a second. All right. So as soon as this initialization process is gone, we will see the first, just the collection itself that has been created within the within the other vector space. Oh, come on. All right. And what we're going to do next then is once that creation is collected, we're going to choose some of that data. Great, it worked. Some of that data, and we're going to populate that live. So let's do that. I'm going to click submit. Let's go back here. And then if I refresh, I can see it here. Perfect. Great. So what I'm going to do next now is I go into the Actions tab. Oh, hang on. No, definitely I do want to change, save those. Perfect. Handy feature. Great. All right. I'll go to the Actions tab. I'm going to create a new data action. What I can do now is I can do the primary, which is all the source data I see here on the left, and I can apply a transform on top of that. I'm just going to take the test collection that I just created, call that demo. And now it gets really exciting. Now I can actually filter what kind of data I want to populate the vector database with. So I actually go in here. In this case, I'm going to select other properties, and I'm going to go to ownership, and I'm only going to vectorize the data that I own myself on that system, that's me right there. Save. Perfect. I'm going to give that a name too. Test demo. All right. And save action. Yes, okay, great. All right. And now I click on run. Perfect. So if I go back to my dashboard and I click on status, I should be able to see that process, right? Perfect. So what that's going to do right now is it's going to start populating the collection. As some of you who are working in the space probably know, that really depends on your embedding model, on the data that you feed in. That might take a little bit or might go a lot quicker. So I'm going to use the spare time in between to get started showing you a little bit of what that chatbot is capable of. So for this one, I vectorized a bunch of my personal files as well as my inbox for Outlook. And I'm just gonna play a little bit the assistant here, and I'm gonna ask him something, knowing about the type and mic situation. I already spelled this out before, which is great. All right, we're gonna paste this here. I'm gonna read it to you. I want to go to this awesome unstructured data event. I just happen to forget where and when exactly it's going to take place. Can you please search my Aparavi inbox, because I remember writing an email to my buddy Royce about it. So let's see. Amazing. And there we go. It comes back with all the information. Fortunately enough, I did make it in time to be here. And it also comes back with the source and tells me where it found that, which was my Outlook inbox. That's great. So that's a really useful application, but maybe for some of you, you think, okay, there could be other things that I can do with this as well. And I would agree, because so as Christy mentioned, I actually come from a different background, which is electrical engineering. So before coming to San Francisco, I was working at a major corporation doing a lot of programming for embedded systems and some other stuff as well. So when I started my first job, I still remember how painful the process was of just going through all the documentation, finding out all the right and relevant hex codes to kind of speak to those embedded systems. And maybe some of you can relate to that. And what I did to kind of help me out here, since I started working there, was thinking, okay, how about if I would be able to vectorize all that documentation and let me just go back real quick and make a chatbot that can assist with doing that. So what you see here is now I changed the collection to the R&D engineering collection, which is a collection that you will find on this side over here as well. And let's see if that already went somewhere. Oh, no. Sure, that's right, that's right. That's a good comment. So I built these two data actions also inside this action here. So I can click on there and click edit. And then you see basically these are the two collections that I built before and there. But let's talk about the chatbot. So what I would like to do here now is maybe I am trying to program this new hardware device. And I'm gonna say copy, duck, and paste. I'm gonna say, hey, I just started this hardware company. At this hardware company, I'm having a hard time programming this embedded system. Can you search our a priori knowledge base for documentation on how to configure the start ranging command? A small disclaimer, I recreated this document from memory. The documentation is falsified for demonstration purposes from my previous employer. And yeah, it's going to give me a bunch of different sources and talking about this start ranging command, which I can actually find, and it's going to tell me exactly what I need to do based on this beautiful document that I created here. So yes, talking about communication interface, steps to take, yeah, and yeah, even giving me some example code on how I could address that. So that's something that at least for me at that time would have been very, very helpful. Yeah, then there's actually one last thing to show. If I look on my class, we still have a little bit of time, which was the semantic and search endpoint that I was talking about. I'm not going to walk through all of this right now, but basically you can find that on our open source library. It will let you connect to the platform. Once you downloaded that, you can you just got to give it in a couple parameters, like where you're hosting it, might be a local host, user ID, then the store path, which is actually related to this aggregator collector node that Joe was talking about earlier. You'll find that on the top here, and then it just goes down the folder structure wherever you want to find your data. And yeah, then you can just go initialize that, send a query, get a response, and it'll give you back these kind of text chunks where, you know, yeah, we have a certain schema that we defined. You get some chunks, you get the semantic relevant result, of course, with the permission ID and so on, a couple other things. Great, all right. Yes, thanks, Joe. Great. All right, let's have a look. No. Bad luck. All right. Oh, we'll figure this out later. All right, let me finish up here real quick. Of course, you've seen this is a very powerful platform. Hopefully, you're convinced of that. Since we are hosting this on our customer side, it has a heavy footprint. That's just something that we want to make you aware of this if you happen to try it, hopefully later. And this comes with some performance challenges, as well as, since we already started working on this a while ago, the user interface might be a little bit outdated at some point, so we're working on that as well. But with all that being said, we'd be super curious to hear your feedback on it as well. And just to give you a little bit of an idea of what's coming on the roadmap, very soon we have our advanced table handling feature that's basically going to make it able for you to not separate tables by chunks, but recognize tables and feed them in one single point in your vector database. Q&A, chat, local LLMs are coming, enforced file permissions, as well as PII anonymization. So meaning that I can identify PII and anonymize it for you, and you can put that into a text output or wherever you want to put it. And yeah, I think that's pretty much it. I want to end this talk with an ask for you, since we have been part of this community for quite some time, and we've put a lot of work in this, and we think there's a ton of value in here. So if you're working in the space and you're developing something similar, give it a try. Let us know. We would love to hear what you think about it. And yeah, we appreciate your feedback. And it's free, right? There you go. Okay.
Thank you. Let's see if we have a few questions from the audience. Okay, I see one. And then if we'll hopefully have, if you have more questions, please speak afterwards.
Thank you for the great presentation. Quick question. I saw you ingested a lot of content. What kind of technical resources do you need in terms of GPUs, CPUs, and the entire indexing process and the chatbots, etc.?
Okay. So yeah, we do require some GPU. I mean, it depends on the size of your data, but GPU will definitely make it run faster. We have our recommended specs posted on our help site. So, I mean, it does require GPU, but like, for example, on my MacBook, I have a 18 core GPU. So yeah. Go ahead.
Sorry, a follow-up question is, can I host it on a server and host it as an API for other users in other applications?
Okay, great question. So we have a variety of deployment options. So what we showed you on the QR code is our Docker download, which is mainly for Docker desktop, but we also have an application that you can install on any server, Linux or Windows right now. Mac support is also coming, but yes, it actually originally was built to be an enterprise platform running on a server, and we've squeezed it into a Docker image that you can download on a desktop, but it is heavyweight for a desktop. But yes, it's made for a server, and you probably saw in the earlier part when I was talking, this thing can scale out basically infinitely. You can just add another node, another server for another set of data. So yeah, it's made for servers.
Yeah. How do you guarantee that the data stays private, and how do you handle that layer that it will not be used by the base models?
So what you do with your data is up to you. What we're saying is you can get all of this intelligence, insight, and take action all within your ecosystem behind your firewall. None of that data goes to Operavi, and you don't have to send it anywhere else. If you choose to use let's say a ChatGPT, for example, you're giving it to someone else. But if you're privacy centric, then you would use a local LLM, not a cloud-based one. If that makes sense.
Yeah, absolutely. Thank you.
Yeah.
What languages are supported?
So we're specifically talking about, like, for example, OCR, we support all Latin and Cyrillic languages at this time. Oh, that was over here.
that was a seeded question. Okay, let's yeah, please hang out afterwards. You can speak to them one-on-one, and let's thank our speakers again. Thank you. So our next speaker is Frank Liu. He's the head of AI and ML at Zilliz. He has a decade of industry experience in machine learning and hardware engineering. He presents at major industry events like Open Source Summit and writes tech content for leading publications such as Towards Data Science. Frank holds an MS and a BS degrees in electrical engineering from Stanford University. And he's going to speak to us today about multimodal embeddings, the workhorses of LLMs.
So I want to thank Christy for the introduction there. And today I want to talk about a topic that's really, really near and dear to my heart personally, and that is multimodal embeddings. But I think before we dive straight into the concept of multimodality and how we generate these embeddings for a variety of different modalities, I want to talk first about the history of embeddings, how we generate embeddings for a single modality, and then we'll talk more about the multimodal aspect of things, where we're going to finish with a quick demo of multimodal RAG. And that's one thing that I'm really particularly excited about because it really ties in some of the things that we learned a little bit earlier today from Encord and from Operavi. So quick introduction to myself. My name is Frank. Pleasure to meet everybody here. I love to see the turnout. I'm currently head of AI and ML here at Zilliz. That's my email as well as my socials if you guys want to connect with me. If you have any questions about some of the content that I'm presenting here, or if you just want to chat about something random, chat about the weather, my figurative door is always open, so feel free to connect with me there. And before I dive into the meat of this presentation, I want to give everybody a quick refresher, right? Why should we care about embeddings? How do these vectors work? And specifically, how does multimodality play a role in unstructured data more broadly? And the key thing to note is that vectors unlock unstructured data. Now, a lot of you have probably seen this slide if you've seen some of our previous talks, or if you're familiar with Zilliz, if you're familiar with Milvis. But really, the core concept is that we have a knowledge base, and that knowledge base can be images, video, audio, text, or as we'll see a little bit later, a variety of different modalities beyond that. We run inference across embedding models. We get vectors from those embedding models, and then we store them inside of Zilliz or Milvis or some other vector database. And these vector databases at their core, they implement approximate nearest neighbor search, ANN search. And ANN search, even though it is a single thing, it is widely applicable to a variety of different applications, and it gives you the capability to generate a lot of insight and analytics over your unstructured data that you otherwise wouldn't be able to generate. So a combination of embedding models, a combination of these multimodal embeddings, these multimodal vectors, plus vector databases, those are really what unlock unstructured data for you and for your organization. And the other thing that I want to mention is that embedding models are the workhorses of AI applications. On the left there, you see Omni-LM L6 v2. That is a text embedding model that is available in the Sentence Transformers library. And on the right, you see Llama 2. So this is actually the chat version of Llama 2. It has been fine-tuned on conversational data. And even though this is a couple months old at this point, you see that the downloads for Omni-LM are about 8x that of Llama 2. And this is really at peak Llama 2 hype. And I think there's good reason for this too, right? It just goes to show you that these embedding models, not only are they good for RAG, not only are they good in a lot of generative AI applications, but they're also good for semantic search, for sentiment analysis, for text classification, and a variety of other applications that you're going to want to build into whatever product it is that you or your organization is building. So this is what is important about embeddings, and this is why you should care, right? Before I talk specifically about multimodality, and before I talk about modern neural networks, I want to talk about the history of embeddings first. And the rest of this talk will be a little bit more ML heavy, but I've tried to tailor it so that for folks who are new to AI and for very, very seasoned ML researchers, in a very particular field, it'll hopefully be interesting for both classes of folks. And I want to start off by talking about, again, this is also very, very near and dear to my heart. I love computer vision, but these are actually what are called handcrafted features. And in particular, the image up on the upper left is SIFT features, SIFT descriptors. I'm not really going to go into how they're generated, but these are very, very early ways of generating embeddings for images, right? If I take the top 10 feature descriptors for any image, I get a dimension 1280 feature vector. And that particular vector I can use just as any vector from either a vision transformer or ResNet or VGG. I can use that to represent my image. Now, this is from 1999. TF-IDF is from the 70s, and Harris corner detector is from 1988. So the concept of embeddings and the concept of vectors, it's been around for a really, really long time. It's just that today we've really reinvented it using neural networks. Circa 2012, ConvNets became popular, and this was the pretty much de facto standard for generating embeddings, even for a lot of language. Circa 2012, 2013, 2014. I got a great chance to be a part of this back in 2015, 2016. I worked at Yahoo. Back then, I built a lot of visual models. We did a lot of model training and putting these models in production as well. But I'm not going to talk too much about ConvNets. I imagine they're probably familiar to many of you here, but the general idea is spatial locality, and specifically hierarchical spatial locality. At the very end, usually the penultimate layer, you take that layer and that ends up being a representation of your unstructured data, which in this case is images. And this is an example of using images and searching for relevant images inside of your vector database. Now, on the left here, we have pictures of food. And if we turn those into vectors using some particular visual model, and we search in our vector database for the nearest neighbor images, the stuff on the right and in the middle is what it corresponds to. Oh, okay, there we go. Not sure what that was about. But that is what it corresponds to. So you'll see that it's very, very semantically relevant. So the first row, for example, it's all French fries. And the second row, that looks like Korean barbecue. And the third and the fourth and the fifth rows, they're also very, very relevant to what we're trying to do. And based on this particular feature alone, you can implement things like recommendation, fraud detection, any type of anomaly detection, obviously RAG, for a variety of other different types of unstructured data. And we're going to get to that momentarily. Hopefully it'll be exciting for folks. Now, around the same time that you saw convolutional networks, you also saw the rise of RNNs, recurrent networks. And this is really the OG language model. This is LLMs before they became large. These are just regular LLMs. The key idea here is that we have a single cell, and that is represented by the blue box here. At every time step, it takes an input defined by X. It has an output defined by Y. And that cell state that is defined by A is the embedding, is the vector representation of everything that RNN has seen up to that timestamp T, right? So even in the 2015, 2016, 2017, embeddings were being used for a lot of natural language tasks as well. Now, obviously today, nobody really uses RNNs. Folks will use convnets, although transformers, I think, have definitely sort of overtaken the visual world as well, the world of computer vision. I have my personal opinion on that, but I'll save that as a topic for another day. And in 2017, we have, attention is all you need. And it introduced the concept of self-attention and transformer encoders and transformer decoders. Now, I'm not going to go into all the details of this particular paper or of transformers in this presentation today. But if you want to know a little bit more, Jay Alomar has a blog called The Illustrated Transformer. I highly recommend it. It's really, really well written, and it will tell you a little bit more about how the transformer architecture works, and in particular, why it works so well for language applications and image applications and many, many other modalities of data as well. But most multimodal embeddings you see today, they are generated with transformers, and in particular, transformer encoders, not transformer decoders. We can, again, get to that in another topic. For text, usually you use something like SentenceBERT, right? You have a pre-trained transformer using next sentence, it's pre-trained with next sentence prediction and with token masking, and that gives you a very, very powerful pre-trained network, which you then fine-tune. Once you have that, you perform pooling on all those tokens, and then you fine-tune it once again with cosine similarity. That is how most modern text embeddings are generated today. So if you find a model on the sentence transformers repository, or if you use something like Cohere's embedding model, that forms the basis for all of these modern day text embeddings. Most modern day vision or visual embeddings use some variant of a vision transformer. This particular diagram is a little bit old. Fast forward 2 to 3 years from the Attention is All You Need paper, you have the advent of the vision transformer. Today, it's a little bit different. Today, they typically use global pooling over all of the actual token embeddings rather than having an MLP head. But the idea is the same. If we can represent an image as individual patches, we can give that sequence of patches into a transformer encoder and have an embedding output just based on that. So again, now we have a single architecture, a single model architecture for generating embeddings for not just text, but also images. So it's really, really powerful, right? And what I want to leave off with, if you get one thing from this presentation today, it is that you're not limited to text and images. There's many, many other unstructured data modalities that you can generate embeddings over. And one of my personal favorites is actually molecular structures. So if you guys have heard of RDKit, or if you've heard of Morgan fingerprints or topological fingerprints, the idea here is that you take the structure of a molecule, right? You take its atoms, its bonds, its functional groups, and you can turn those into what is typically a binary vector and represent that molecule as a fixed length vector stored in your vector database and be able to search for nearest neighbor molecules. That's very, very powerful, right? The same thing for audio modalities. And this particular diagram here is WaveTech 2.0, I believe. And that is actually taking a convolutional feature encoder and using that as input into a transformer, into a bidirectional transformer. Same thing for graphs. If you think about, let's say, fraud detection or anomaly detection, if you're a big bank, you can take transactions. These transactions are represented as nodes within a much, much larger graph of, let's say, individuals. You can take the adjacency matrix and you can project that into a list of embeddings, one embedding for each node. And with that, you can do fraud detection. You can do anomaly detection, right? You can find individual nodes that maybe are similar to other nodes which are fraudulent or not. right? And that is one of another powerful way that you can represent graphs or represent these individual data structures as embeddings inside of your vector database, and again, be able to generate insights out of that. And the last one that I'll leave off with is time series data. Time series data, this particular one, I think it's called TS to Vec. And what TS to Vec is doing is it's taking time series segments and it's contrastively learning segments that are similar to each other within a hierarchical feature map as well. So again, there's many, many modalities of unstructured data that you can vectorize, store in your vector database, and generate those insights and generate those really, really key ideas based off of that. So it's a really exciting time for us, right? We've seen LLMs, we've seen, text modalities, we've seen RAG 1.0, and now we're really entering an era where all these LLMs are becoming multimodal, and we're going to be able to basically shove all sorts of unstructured data in there and get insights out of them. So last but not least, I'm going to talk about multimodal embeddings. There's only 2 slides for this particular section, and that's because multimodal embeddings are still, I would argue, fairly new. This is CLIP from 2021, and CLIP is essentially taking a text encoder and a visual encoder and using a form of contrastive loss. I actually don't quite remember what this is called. It's a form of NCE loss. I think it's called N squared loss or something like that. And what it's essentially saying is I want images and text in a single batch that are close to each other. I want them to be, I want those values to be high, those similarity values to be high. And I want the similarity values represented here by the dot product of text and images in the same batch that are not similar to each other. I want those to be very, very low. So that's essentially what CLIP is doing. And the output of CLIP is it's embeddings, right? So you have embeddings over both text and images, and they're embedded into the exact same space. Now, if you recall, the Encord presentation, these multimodal embeddings, there's sometimes some finagling that you have to do, a lot of data cleaning, and it can be challenging to get those to a state where you are happy with them. But we're seeing more and more data out there. We're seeing better data sets, and we're seeing more ways with which you can generate these multimodal embeddings. And this is actually a paper from 2023 by Facebook AI Research, or Meta AI, I believe it's now called. And this is actually taking 6 different modalities of data. So there's audio, visual data, so images and video, depth maps, text, and then the last one is IMU data. It's not represented here, but you can really see the power of these multimodal embeddings just based off of this one diagram. And the key idea is that if I take audio, if I take vectors that correspond to the audio of a crackle of a fire, and in my vector database, I retrieve visual data that's close to it, I retrieve depth maps that are close to it, and I retrieve text that's close to it as well. These are the results that I get. So you can see they're very, very relevant, and it's very, very cross-modal. Same thing for a baby cooing. You can see that the results there are very, very relevant as well. I'm not going to talk too much about embedding space arithmetic or about audio to image generation. I found that tends to confuse audiences a little bit more, but I'm happy to chat about that with anybody who's interested after this presentation here. And let's see how I'm doing on time. So I actually have quite a bit of time. I have a sort of like a bonus demo of multimodal RAG, and then at the very end, I can take some extra questions if the audience members have them. But right now we're in the middle of this generative AI boom, and multimodality and RAG, oftentimes people don't think of them as being used together just yet. But I want to show you a glimpse of what the future beyond 2024, beyond 2025 looks like. So I'm going to stop the slides here. I'm going to go to this demo. Make it a little bit bigger. The key idea behind this particular demo is that we're taking multimodal data and we're using the ImageMind model that I just showed you to store that multimodal data inside of Milvus and retrieve it very quickly, again, using Milvus, so that we can give it as context into a multimodal large language model, or an LMM, if you like to call it that. What I've done here already is I've actually taken the Google I/O pre-show. Has anybody actually seen Google I/O this year? And we got a couple of hands. So the pre-show was, I don't really know how to describe it. It was a musician, a freestyle musician. He crawls out of a coffee mug, a human-sized coffee mug. Oh, yeah, he's going crazy there. But he crawls out of this human-sized coffee mug, runs across the stage, and starts putting on this show. And he does a display of Google's new generative AI capabilities when it comes to audio, when it comes to music. I think it's called like, I forget exactly what it's called, like VFX or something like that. But anyway, it's okay, right? But it's a crazy video. There's a lot of stuff that's going on in it. And we want an LLM to be able to ask and answer questions over it, right? So what do? How do we do that? I've already populated my Milvus vector database. It's running directly inside of this Jupyter notebook. I've already populated it with frames and audio snippets every 5 seconds from this particular video. Again, I'm not doing that here because it just takes a little bit too much time. I've already done that population. And what I'm gonna do is I'm gonna build a very, very simple, sort of like a RAG system in a notebook showing you multimodal retrieval in action. So for this particular demo, again, I'm using PyMilvus. In this case, I'm using Milvus Lite. We've talked about Milvus Lite at a couple of different previous unstructured data meetups, but it's basically, as I mentioned earlier, a version of Milvus that you can just run directly inside of Python. You don't need to stand up either Milvus standalone or Milvus cluster. We're going to download the Google I/O pre-show, and the LLM that I use for this notebook is actually Meta's Chameleon 7B. Anybody familiar with that? Okay, actually very, very few hands. I'm surprised. Chameleon 7B is an open source large language model that was actually trained probably about 6 months ago, but it was released very, very recently by Meta AI. And it is a vision plus language model. So it is a VLM, if you like to call it that. The key idea behind Chameleon is that you can give it images as well as text and ask it to, to answer questions about that image, or to, to generate some insights from that image, and so on and so forth. So because I've already populated my vector database with all the data that I need, first I'm going to restart everything here actually. First, I'm going to connect to my Milvus client. So I'm going to connect to that very quickly. And then here I'm using a library called Radiant. This is a library that I actually developed myself to really make it easier to work with a lot of multimodal embeddings. I'm going to create a text vectorizer using the image bind model. So I'm not sure how long this is going to take to run, but you can also create multimodal vectorizers. So vectorizers with all 6 heads in there. In this case, I'm only taking the text head because it'll load a little bit quicker. And I'm going to give it a prompt, right? What was unusual about the coffee mug on the stage? And I'm actually going to play this so that you guys know what's going on here. So this guy, Mark, he crawls out of this coffee mug, or he falls back in the coffee mug first. Then he crawls out of it and starts to do this performance on the stage. So that is what is relevant to this particular demo, specifically for this demo notebook. Now that we have the prompt here as well. We're going to vectorize this particular text. We're going to vectorize the text, and we're going to search our pre-populated vector database for images and audio that are similar to this text, which I've taken from the video, basically. So we're going to do the vectorization there. Should be pretty quick. So you see it gives us a vector. Now we're just going to do multimodal RAG. So this is the first retrieval step. I'm going to create a Milvus client. Again, hopefully that works. Okay, it works. We're going to search for the results. And then what I'm going to do is, this is the top result. I've specified a top K of 1. So I'm only searching one single result inside of my vector database. And this is the result that it gives me. So this is what ImageBind and Milvus believe is the most relevant image to my query. And you can actually see it is very, very relevant indeed. So again, I've taken frames every 5 seconds and audio snippets every 5 seconds and inserted them into the Milvus vector database. Here, this is the most relevant image to my prompt. And I've retrieved that just by specifying that I want the modality to be the image modality only. Now, once I have that, I can create my prompt. This is how you create a prompt with Chameleon. And unfortunately, I can't show you this last step. My laptop doesn't have a GPU and also doesn't have enough RAM to run it. But I've actually run this on an A100. Eventually, when Chameleon becomes available on Hugging Face, hopefully in less than a week or so, you'll be able to run it on CPU. If you want to run it, you have to use a GPU with enough memory. But this is the code that you would use to run it. And if you run this, you'll see it should give you something like this. I'm gonna make it a little bit bigger. The unusual aspect of the coffee mug is that it seems to have a person crawling out of it. And again, your mileage may vary, your results may vary. based on the temperature that you set, based on how many times that you run the LLM. Truth be told, it took me a while to get this output, but if you use a larger Chameleon model, if you use, let's say, Chameleon V2, V3, as these open source models become better and more relevant at picking out the best parts of your data, you'll see better and better results. So I'll probably figure out a way, Christy, I'll figure out a way together. We'll see if we can get this notebook shared with our audience here, but I have a couple of extra minutes here, so I'm happy to answer any questions that any of the audience members might have.
Thank you. Great presentation. I was curious, have you encountered specific examples or like situations in which using this multimodal approach was like more effective? Have you done like sort of A/B side by side?
Yeah, so in certain cases, you have to use multimodal data. And the reason why I use this video, well, I guess, first of all, I thought it would be cool for an LLM by Meta to answer some questions about a Google video. But the other aspect of why I use this video is because there's no real description, like the text description of this video out there. It's not in, it's not in the description for the video. It's probably in some of the comments. Okay, yeah, we're not gonna go there, but it's probably in some of the comments. But the idea is that you can only get this from the image, or you can only get it from the audio snippets. I'm actually gonna run this, I forgot to do this, I just realized. I'm actually gonna run this with just the audio modality as well, just to show you guys that it is truly multimodal. So in this case, it picks out a particular audio snippet. It's not, my guess is that it's not that relevant. But if you have, once GPT-4o, it opens up its audio capabilities, you can get audio and images and frames and visual data, stuff all that into the context window, and really truly be able to, utilize all of your data to do RAG, right? But again, the reason why I wanted to show this video is because there's no description of what's going on. And even if someone described what's going on, you probably wouldn't believe it. Like a guy's crawling out of a coffee mug, what the hell is that, right? But yeah, great question.
Any more questions? I see one here.
Oh, we got one in the back there first, so sorry. But yeah, you'll be up next.
Yeah, since you pointed out that you had limited GPU on your computer, but have you thought of using some of the online quantum computers available by Google and Meta? Do you think, combining RAG with quantum computers, we can have this available in fraction of seconds?
So I don't know a whole lot about quantum computing. I have to be very, very honest. From what I do know about quantum computing, it is able to cover many, many individual states at once. So what I could see a quantum computer doing is, instead of me pressing enter, 100 different times to try to get this particular output, it could get a list of, let's say, maybe 100,000 or 1 million outputs that the LLM could potentially ever generate given my inputs. So it would be faster. I could see that being a reality in the future. But in the interim, I think the only way to do it is if you go to Google Colab, you buy some credits, and then you select A100 in the dropdown. That's the best way to do it.
Thank you.
Yes.
Thank you for the presentation. There was a link in one of the slides that you talked about illustrated transformers.
Yes.
How can we access that? So
if you actually just Google the illustrated transformer, you'll see it.
Oh,
yeah, if you just search for it, or I'll click on it too.
But you also have a little some other links as well. Is there a way for us to access this specific slides?
Christy, I'll share the slides. We'll put a comment with all the slides from both this presentation as well as from the previous two presentations, if we can, and then we'll have those in the comments section for the Luma page.
That's great. Thank you.
We'll put it in YouTube.
YouTube, that's even better.
Okay, we'll put it everywhere: LinkedIn, YouTube, Twitter. Okay, one more question.
Hello. Really nice presentation. I wanted to ask, I have two questions. First is what similarity search were you using while you showed the demo? Were you using any cosine similarity or phase-based, meta-based search algorithm? And second is, Are there any edge cases? Like I've seen the embeddings, right? Like not covering entire context of the images. Sometimes when you ask them niche questions, they do not cover the entire context of the images. And are there any edge cases? Like, have you faced that?
Yeah, so when it comes, so first of all, cosine similarity is being used here. Second of all, when it really depends on, so the attention mechanism, pretty much all of these language models, they use causal language modeling. So they're trained causally, right? So they have non-bidirectional attention. A lot of it, you can actually visualize what tokens your prompt is attending to. And if you don't get the results that you want, it means that typically that wasn't seen in your training data. And you can actually visualize that. There's a lot of ways you can do, yeah, well, I mean, that's exactly what the attention mechanism is for. Usually, if you aren't getting the results that you see or that you want, it's because the prompt or what you have in the prompt, what is being attended to inside of the image, it's just not there yet. There's no way, there's actually a lot of, I've seen many of these cases. So one of the outputs that I get for this particular example here, one of the outputs I get is that, I forget exactly what it is, but Chameleon says that there's a weird Apple logo on the mug and that it looks ugly or something like that. Right, it's Facebook, I guess, throwing shade at Apple, but there's it's very, very hard for me to say, and oftentimes I will say, typically because because that attention mechanism, because it's global in nature from the very first layer, it has trouble recognizing individual textures, and it has trouble recognizing, let's say, thin lines or let's say very, very small items. So it's one of the things, I mean, it's one of the downsides of sort of just global attention. I hope that answers your question. I think it did somewhat, but we can always chat about it afterwards. All right.
Okay. Okay. One last question.
Okay. One last question.
Hi, Frank. It was a nice presentation. My question is, in this demo, you show us a YouTube video. So nowadays in this AI era, few days ago I visit another meeting, and in that I saw somebody make a video based on our text. So if in this kind of AI transformation, is it working or not? And also you show us your demo, it depends upon this video and pictures. So sometimes is it capture any audio and text or not?
So it actually currently the text is not captured. So if there's text that appears on the screen, so for example, morning here, this is not captured by the models that I'm currently using. The best way to capture it would be to run through something like Tesseract or some other OCR model, extract that text, and then run that text through a text embedding model, and then have a reverse index back to the original frame that it came from. But what you see here is purely the image. It is the semantic content of the image. It's not the text that appears in the image, and then the semantic content of the audio. So if it actually doesn't index. I haven't indexed what. Well, okay, that's weird. I haven't indexed what the musician here actually says as a part of this presentation. But you can, right? You can. So you can run, again, you can take the visual data, embed the visual data directly, have another sort of head that runs Tesseract or runs some other OCR model in it, and then embeds the output of that. And then you can do the same thing for audio too. You can have, you can transcribe that audio, and you can have another head that just embeds the audio directly.
Okay. And what about these subtitles?
I actually didn't download the subtitles, so I used YTDLP to download this YouTube video, and it just I was unaware that you could actually use it for subtitles. But if you can, that's another option. That's a great point.
Okay, thank you, Frank.
All right, so let's thank our speaker, Frank, again. Okay, so we're going to show the code so people can, I can spin the dial. And then while I'm setting up for that, I want to see if anybody has any jobs that they would like to announce.
Maybe I can stand. Yeah, I'm Srinivas. I'm from a very early startup called Zoom My Life. I worked in healthcare for 20 years. We are trying to generate a health AI company. Basically, it serves individuals, not the providers or payers. That's where our focus is. We want to give the best health possible or advice using AI. So right now we have openings for CTO, Chief Technical Officer, and also some full stack developers, and also a few interns. I will be here for some time. Just you can collect our information if you're interested. We can talk more about it. Thank you.
Sure. So thanks, Chris. I'm Adam. I'm running recruiting right now over at Zilliz. We do have a variety of openings right now. We are certainly growing our sales team. But beyond that, we're also hiring for engineering on the cloud side of things, both in terms of like infrastructure services as well as SRE. We're going to be looking for core database developers, as well as folks to work on some of the deepest layers of the algorithms, so on the sort of high performance computing layer. So if you do want to talk, I'll be here for a little while. Also, you can find us on zilliz.com/careers. Feel free to connect with me on LinkedIn. So we are definitely actively hiring and planning on growing fairly aggressively in short order. So really appreciate everybody coming out and being a part of this event. So thanks, Chris.
Sam, did you want to say anything?
Well, Adam covered it. So hi, I'm Sam. I'm part of Zilliz. I've just joined a month ago. I'm excited to be here. I just wanted to build off what Adam was talking about. So on the sales side, we're looking for account executives, if you know any, that are good both here in San Francisco and also New York. So those are our preferred locations initially, as our step one before we start really building out our sales organization. And also we're really looking for some good solution architects. So folks who have technical abilities, you got to be able to code in Python, have that capability. So if you know anybody who wants to be or is customer facing and has that background, please come talk to me or Frank, who was just speaking. Thank you.
Anybody else? Oh, I see. Okay.
Hello, I'm Elliot. I'm an AI engineer at Archify. So what we do is automate Excel financial models like DCF, LBO, things that investment bankers do. We are looking for AI engineers with like 70% software engineering and then 30% AI. But yeah, I think we're probably going to get like 2 or 3 more on the team.
Is that it?
Oh, yeah, we have one more. We are growing our SF team and we're looking for a developer advocate. So someone who can code, someone who can give these kinds of presentations and far better than I did. And also who can grow our online presence and be able to communicate the technicals of our platform to users.
Great. All right, great. Well, I want to thank you guys. One last chance to star our GitHub and be entered in the lottery. Meantime, just want to say we organize these events so people can learn together, collaboratively, have meaningful discussions about how to use generative AI and unstructured data. So thank you for showing up, and please find any one of us Zillizers if you are using Milvus or Zilliz and would like to present. Thanks. Thank you for coming.